this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the next topic, threads. So as we all know, process is a basic unit of execution. Likewise, a thread which is a basic unit of CPU utilization. So in a process we will have one single thread or you can have multiple threads. So thread forms the basic unit of the CPU utilization. So the thread consists of or it comprises of thread ID. So a thread ID is nothing but a unique ID to define which thread is that or to identify by the operating system which thread is the particular one. So each thread will have a unique thread ID. Then a program counter. So as we all know, a program counter is nothing but the instruction that is scheduled, the next instruction that should be executed will be stored in the program counter. Then we have registers. Registers are nothing but the faster ones which can be taken from this processor, so that when something is available in the register, it could be easily accessed by the processor for executing. Then we have stack. So stack portion is nothing but, as we all know, a stack will consist of the global and static variables that are used by the programmer. Then so these are all the common things that a thread consists of, and also if there are multiple threads, it shares with other threads belonging to the same process. So when a process consists of multiple threads, then it may share its code section, its data section and other operating system resources such as open files and signals. So as we all know, a traditional heavyweight process has a single thread of control. If a process has multiple threads of control, it can perform more than one task at a time. So looking to the single threaded process, so it consists of code, data, files, registers, stacks. Whereas when you see a multi-threaded processes, you have code section, data section and file sections are shared by all the threads of that particular process, and each thread consists of a unique register and stack. So registers and stacks are different for each thread even though if it is available in a particular process. So this is how a single threaded process and a multi-threaded process will look into. So if a process has multiple threads of control, it can perform more than one task at a time. So what are the benefits of using threads? So there are 4 unique benefits of using a thread. So the first one is responsiveness. So multi-threading is an interactive application which allows a program to continue running even if a part of it is blocked or if it is performing a lengthy operation. Resource sharing. So the thread shares the memory and the resources of the process to which they belong. The benefit of code sharing is that it allows an application to have several different threads of activity, all which contains in the same address space. Economy. So allocating memory and resources for process creations is costly because thread shares resources of the process to which they belong. So it is more economical to create and context such types of threads. And the final one is utilization of multiprocessor architecture. So the benefits of multi-threading can be greatly increased in a multiprocessor architecture where threads may be running in parallel or in different processes. A single threaded process can only run on one CPU no matter how many are available. Multi-threading on a multi-CPU machines increases concurrency. So we all know what is a multiprocessor architecture. So if a server is present and if a client comes with a request, the server will create a thread based upon the request and it will again go and listen to some other response if it is needed. So in operating system, there are 2 types of threads, user level thread, kernel level thread. So user level thread is nothing but they are supported above the kernel and are managed without the operating system support. Kernel level threads are supported and managed directly by the operating system. So there exists a relationship between user threads and kernel threads. These relationship we call it as the models. So that there are 3 common ways of establishing this relationship: many to one, one-to-one and many-to-many. So this is an example of many-to-one model. Many user level threads are mapped into a single kernel thread. So here the disadvantages, if a blocking system call is made, then the entire process is blocked. Even if other user threads would otherwise be able to continue, could not able to continue. So for this we gone to one-to-one model. So in one-to-one model, separate kernel thread is mapped to different user thread. So here the disadvantage is significant overhead involving more number of kernel threads with the user threads. So this will significantly have an overhead. So finally we are going to many-to-one model. So in many-to-one model, many user threads are mapped to different kernel level threads. The only condition is the kernel thread should be equal to or less than the user level thread. So this process can be split across multiple processes. So if there is any blocking kernel system, then the other kernels might come into execution. So this is the main advantage. So many-to-many model is mostly used in the operating system. Thank you.